Hi everyone, welcome to mathworldm. This is Cambridge International AS and A-Level Further Mathematics Paper 2 for October-November 2022, and the code is 9231/22. Okay, so in this video, I'm going to show you the solution for question 1 and question 2. Okay, so now let's move on to question 1. 1a, find the set of values of k for which the system of equation has a unique solution. So for unique solution, we know that it means the determinant of the matrix M is not equal to 0. So what is the matrix M? The matrix M is basically the matrix that consists of all the coefficients of the variables. So from here, I will write the coefficient for the first term is 1 because it's 1x. So 1. Then the coefficient for the y is basically plus 2. I will just write 2 here. And then the next one will be 3. So that is our first row of the matrix M. And then for the second row, it will be k plus 4 and plus 6. Okay. And the third row will be 7 plus 8 and plus 9. So we will just write 7, 8, and 9. And it will not be 0. So we just need to solve this equation, right? Then you'll be able to find the k. So now, since this is determinant of 3 by 3 matrix, so what we do here is probably you can just fix the first row. I will fix the first row, and then I will consider the columns. So for the first row, you need to label the sign first. So the first row, the sign will be plus. The first row, first column element will carry the plus sign, and the first row, second column, which is the 2, will carry the minus sign, as well as for the first row, third column, which is the 3, the sign will be plus because the sign will be alternate. All right. So after that, you just consider the first column. So when you consider first column and first row, you are fixing the first row, and then when you consider first column, the cross out is 1, and the sign is plus. Therefore, our working is plus 1. Then the leftover terms 4, 6, 8, 9 will be in the determinant. Will be the determinant of 2 by 2 matrix. Okay. So now same goes to the second column. So just now we were fixing first row and consider first column. Now we are going to move on to second column. Means that you are considering second column right now. Then the cross out will be 2. Okay, and the sign is minus. So from here, I will be getting minus 2. Then the determinant of the remaining terms, k6, then 7, 9. Okay, and then followed by plus 3, which is considering the third column. So when I consider third column, right, my cross out will be 3, and the sign is plus. So I will write plus 3. This is how I get it. And then the remaining terms will be, or remaining elements will be k, 4, 7, 8. Okay, and not equal to 0. So this is how we count the determinant for 3 by 3 matrix. So now we have reduced the 3 by 3 determinant to 2 by 2 determinant. So very simple, just get the cross multiplication and minus the second cross multiplication. All right, so you'll be getting plus 1 bracket 4 times 9. Okay, 4 times 9 minus 6 times 8. And then minus 2. Same for the next one, it will be 9 times k minus 6 times 7. And plus 3. Then 8 times k, so 8k minus 4 times 7. And not equal to 0. So now we just need to solve this, and you'll be getting the answer. So 4 times 9 minus 6 times 8, you'll be getting minus 12. Okay, here minus 2, here is 9k minus 42, then plus 3, 8k minus 28, and not equal to 0. So when you do expansion, you'll be getting minus 12 minus 18k. So minus 2 times minus 42, it will be plus 84, then plus 3 times 8 will be 24, then followed by k. 28 minus 28 times 3, you'll be getting minus 84 and not equal to 0. So when you solve this left side, you will get 6k, okay, that's not equal to 12. So I will move all the numbers, all the constants to the right side. So obviously your k is not 2. So when your k is not 2, you will be getting the unique solution. So this is how we solve 1a. Right? So now let's move on to 1b. Okay, interpret the situation geometrically in the case where the system of equations does not have a unique solution. So now, basically, if it has unique solution, that means the k value will be not equal to 2, means that we can accept any k except 2. So now, in the part B, it does not have unique solution, which means when the k equals to 2, the system of equations does not have the unique solution. So I'm going to replace the k by 2 in the system linear equations here. So you rewrite the equations. So the first will be x plus 2y plus 3z equals to 1. So I will get x plus 2y plus 3z is 1. Then my second equation, my k is 2. So second equation becomes 2x plus 4y plus 6z is 0. So 2, 4 plus 6z equals to 0. Or 2, 4, 6 will be the coefficients for x, y, z. Then the third equation, it will be 7x, 8y plus 9z equals to 3. So 7x plus 8y plus 9z equals to 3. So from the second equation, it is divisible by 2. Therefore, it can be reduced to x plus 2y plus 3z equals to 0. So from here, you will notice that the first two equations, the left-hand side of the first two equations are the same, which means they are parallel. Okay? But unfortunately, the right side for both equations are not the same. The first one is 1, the second is 2. So our geometrical interpretation will be, there will be two parallel lines. Okay, there are two parallel lines because of the first and second equations. Or two parallel planes, I would say it is a plane because it is 3D, okay, x, y, and z. Two parallel planes. And then another one will be different because the coefficients will be 7, 8, and 9. Okay? And another plane is not parallel. Okay? But from the parallel planes, then you can further explain. So when they are parallel, okay, they might be the same or they might not be the same. So, but then when you look at the right-hand side, the first one is 1, the second one is 0, which means the parallel planes are not identical. Okay, so this is the geometrical interpretation when the system of equations does not have a unique solution. So we will just need to replace a k value and then you try to simplify. All right, so that is for question 1. Now, let's move on to question 2. Okay, question 2. A curve has equation x plus y in bracket multiplied by what x plus 1 in bracket multiplied by y plus y squared equals to 2. Now, first part, show that dy dx is negative 2 over 3 at the point 0 minus 2. So now we need to show dy dx. So now you are given the implicit equation. So what to do? I'm going to use the implicit differentiation to differentiate. All right, no need to get the y as a subject. Just differentiate as usual. So now, since the first term has or consists of x plus 1 multiplied by y, we are going to apply the product rule. Okay, so we are going to apply the product rule. So according to product rule, we need to keep the first, which is the x plus 1, and differentiate the y with respect to x, because you need to find dy over dx. So here, you differentiate y with respect to x is basically 1 times dy dx using the chain rule. Then plus, keep the y and differentiate x plus 1. It will be 1. This is found using the product rule. And then plus, when you differentiate y squared, it will be 2y. Okay, after that, you multiply by dy dx. Then right-hand side, the 2 will be 0 because there's no x. It's a constant. Now, once you have found this, okay, so according to the question, you need to show the value of dy dx at the given point. So we do not need to get the dy dx as a subject. So you can just directly replace the x by 0 and the y by minus 2. So when I replace, I will get 0 plus 1 dy dx plus y times 1 is basically y. So I will replace my y by minus 2 plus then 2 times my y. Y is minus 2. Then dy dx equals to 0. Okay, so from here, when you simplify the first and third term, so the first term is 1 dy dx. The third term is minus 4 dy dx. So you will be getting negative 3 dy dx. And then this minus 2 will be moved to the right side because you need to get dy dx here. So from here, obviously, your dy dx will be negative 2 over 3. Okay, so we solve this question using implicit differentiation. Okay, so now let's move on to the part B. So for part B, find the value of the second derivative at the same point. All right, so now we need to refer back to the previous solution. So before you get the second derivative, you must have found the first derivative. Now, I may just refer to this answer, okay, this step in the A to get the second derivative without getting the dy dx as a subject. Okay, therefore, I need to rewrite my first derivative expression from the previous part. So, y times 1, I will just express as y plus 2y dy over dx equals to 0. Okay, now when you need to get second derivative, the concept is same as the first derivative. And now you are getting implicit differentiation, okay, because I am not getting the dy dx as a subject, so I will call this as implicit differentiation. All right, so what to do is, since the first term consists of product of two terms, the first is x plus 1, the second is dy dx, then again, I'm going to apply the product rule, okay? And I will be differentiating the whole equation with respect to x as well. So first of all, according to the product rule, keep the first term, okay, keep the x plus 1, differentiate dy dx with respect to x, which means that is a d squared y over dx squared. Plus, now you keep the dy dx, okay, and then you differentiate x plus 1, it will be 1. Now, move on to the second term, which is the y. When you differentiate y with respect to x, it will be just 1 dy dx. So I will be getting dy dx, right? And then for the third term, again, there are two terms, the multiplication of two terms over here. So again, we are going to apply the product rule. So keep the 2y, keep the first term, differentiate dy dx, you'll be getting d squared y over dx squared. And then plus, keep the dy dx, and then differentiate 2y with respect to x, you'll be getting 2 dy dx equals to 0. Okay, so once you have done this, no need to get the d squared y over dx squared as a subject, we can just directly replace the x and y together with the dy dx that you have solved in the A. So I will write at 0 minus 2 dy dx is negative 2 over 3. Okay, so now replace all the values. So the first term, x plus 1. So again, I get 0 plus 1 d squared y over dx squared. And then plus dy dx. So this dy dx will be replaced by negative 2 over 3. Okay, and then plus another dy dx. So negative 2 over 3 plus 2y. My y is minus 2. Then d squared y. Plus, okay, now here is 2. This dy dx times dy dx will be squared of dy dx. So I square the negative 2 over 3. Then equals to 0. Now, from here, you just need to simplify. Okay, so the first one is 1 dy dx. So here is 1 1 d squared y over dx squared. And this is minus 4 d squared y over dx squared. So when I total up, it will be negative 3 d squared y over dx squared. Okay, so for the rest of the constants, it will be moved to the right side. So here minus 2 over 3, minus 2 over 3, and this is 2 times negative 2 over 3 squared. So when you get the total, it will be 4 over 9. Okay, when you move all the ticks, the green ticks to the right side. So from here, right, so divide the 4 over 9 by negative 3, I will be getting negative 4 over 27. All right, so that's all for this video. Right, if you like my video, please do not forget to subscribe to my channel and stay tuned for the upcoming videos. All right, because in the next video, I'm going to show you the solutions for the remaining questions. Okay, thank you. Bye.